Hello everyone, and welcome to today's webinar, Achieving Continuous Testing Through Test Optimization and Automation. Before we get started, I'd like to go over a few items so you know how to interact in today's webinar. You'll have the opportunity to submit questions to the presenters by typing them into the questions window of the control panel. The control panel is situated on the right-hand side of your screen. You can submit questions at any time during the presentation. However, questions will be addressed at the end of the webinar. Today's webinar will last for approximately 45 minutes with 15 minutes at the end for your questions. I would now like to introduce you to our presenters, Gerie Owen of QualiTest and Nikolay Advolodkin of Source Labs. Over to you, Gerie.
Good morning and good afternoon, everyone. I'm Gerie Owen. I'm the QA Evangelist at QualiTest, and my co-presenter is Nikolay Advolodkin, a Solution Architect. Nick, would you like to say anything about yourself here? So let's go ahead and talk a little bit about our agenda. We're going to talk about continuous testing, and a big part of continuous testing is test optimization and test automation. But first, just to begin, we will go ahead and say a little bit about QualiTest. We're the largest pure-play independent testing company in the world. That means testing is all we do. We have over 3,000 testing professionals worldwide. We're industry and technology experts. We provide outcome-based testing with contractual guarantees for quality improvement and cost reduction. We do managed testing solutions, long-term and SLA-based outsourcing. And finally, we provide a global service delivery model, including onshore, nearshore, on-site, and offshore and crowd testing. So let's talk a little bit about Source Labs. Nikolay?
Hi everyone. My name is Nikolay Advolodkin. I am a solution architect at Source Labs, and basically Source Labs is a cloud testing platform that allows you to do cross-browser and cross-platform testing for all of your web applications, and we basically host that Selenium grid so that you can run your test automation on Appium or Selenium and make sure that your application is functioning perfectly on all of your favorite devices.
Okay, so let's talk a little bit about continuous testing. Well, what really is continuous testing? First of all, it's really the basis for continuous delivery, because without continuous testing, you can't have continuous delivery, much less continuous deployment. Continuous delivery now requires not only increased velocity, but more importantly, increased quality. We must shorten our test cycles, and with the increases in microservices architectures, they require high-quality functional testing, including automated API testing. So there's at least one place we need to automate, but we also need to automate our builds, our integrations, and our deployments. And we have to not only integrate testing throughout the pipeline, but also test our integrations and deployments as well. So the definition that Forrester tells us continuous testing is that it's a core capability in Agile and DevOps where all testing activities run continuously in an integrated fashion with development and delivery. Bug fixing is enabled immediately. Test environments are provisioned instantly. Unit functional and non-functional tests are run in an automated way, all orchestrated by the continuous integration and continuous delivery tools. Well, that's quite a mouthful. So what is it really? Well, it really is about risk analysis and process improvement, as well as the implementation of automated tools throughout the entire software development process. It requires shift left. That means moving automated testing to the lowest levels of the test pyramid. And that's a really important part of the approach. Continuous testing really is about managing risk. Now, shift left, and I'm not sure if you're aware of the test pyramid, but basically what that is that bulk of your tests, especially your automated tests, need to take place in the automation, in the unit testing layer, getting continuously fewer tests as we go up. We would do the integration and API, and then finally the functional testing, and just at the very top, your acceptance testing. Just a small amount of those tests will be automated. So continuous testing, of course, requires automation. However, it encompasses more than that. It's really an approach to managing risk. And the way we manage risk is focusing not only on improving our test efficiency, but also, and more importantly, the effectiveness of our test processes. When we automate scripts, we write them, we run them, we look at them, and there's wait times in there and delayed feedback. In continuous testing, we include the automated feedback. There's no human intervention until we get feedback saying something failed. So that's a big difference. Now, let's look at some of the attributes of continuous testing. Well, of course, the main one is the assessment of business risk. And coverage and business risk coverage is our primary goal here. Continuous testing establishes a safety net that helps the team protect the user experience. You know, as testers, we're the champions of the user, and in that way, we're the guardians of our customer's reputation, because if the users have a poor experience with our website or our mobile app, they're going to go somewhere else. And that's going to be lost sales and could be even loss of reputation for our organizations. So that's a really important aspect of continuous testing. Continuous testing requires a stable environment and production-like environment to be available at all times on demand. Now, what that requires is being able to spin up environments using service virtualization. Continuous testing integrates seamlessly into the software development pipeline and the DevOps delivery chain. There again, it's kind of the underpinning of the whole chain. And it delivers actionable feedback that's appropriate for each stage. These are the automatic feedback alerts. And that's a really critical thing, because if we don't have the feedback automated, then we don't have the true value of continuous testing. Now, continuous testing minimizes risk in a couple of ways. One is test optimization, and the other is automating throughout the pipeline. Now, we've talked a little bit about automating throughout the pipeline, but now what we want to talk about is test optimization. So test optimization, the most important thing I think to realize about it is that it's an ongoing process. It's not just, okay, go through your entire regression suite, pick out the ones you don't need, pick up the ones you do need. Okay, that's done. That's what we use forever. It's an ongoing process, because with continuous delivery, you're constantly bringing in new features. That means your test bed, your test cases are always changing. So we start with the regression test suite, RTS. We need a mechanism to track how the tests are doing. You know, are some good or some bad? Then we do a periodic cleanup, and we use metrics to continually analyze how our testing is doing. Is it effective? That's all part of continuous testing. So there are three ways of implementing test optimization, and we really need to do all three. First is optimizing the test scope, then we optimize the test cases, and finally the test suites. Now, in optimizing the test scope, we need to select end-to-end tests that focus on the critical and high-risk features of the application. We need to understand all of the integrations involved in the critical user workflows, including the technologies that are employed in these applications. We need to know what we're working with. Are we working with web, mobile, the message API layer, more likely all of them? But we need to know any critical things that are different from applications that we work on all the time. And given that we need production-like environments in an instant, we need to implement service virtualization. And we need to implement service virtualization for integrations and components that aren't readily available, because we need to run the end-to-end tests early and continuously. We need to run the end-to-end tests as early in the process as possible, and very often not all the integration components are going to be ready. So we need to be able to stub them in using service virtualization. We also need to use the most realistic data possible, and sometimes we may need to use synthetic data generation for that. And finally, we need, as much as we need to automate everything we can. And that means there are going to be aspects of the testing that we cannot automate. We need to recognize what those are, and we need to use exploratory testing to do those, to complete our test coverage. Exploratory testing is what's going to find our user experience bugs and other bugs that may not be easily found by the automated tests. Now, optimizing the test cases is very important. This is, again, and this has to be done constantly. So we need to make sure first that the tests are focused on the functionality, they are validated. You don't want to, it's one validation, one test. We don't want long multiple tests that include multiple validations, because if we do that, it's going to be really, really difficult to debug. Tests should always be written as simply as possible, although to automate them, they do need to be down to the click level, but we want to reduce the complexity of the test. Because if we have a very complex test, it's going to require more validation, and sometimes we're going to be validating the test code more than we're going to be validating the code itself. And finally, even though service virtualization can fill in missing components, tests need to be as independent as possible. And I'm sure Nikolay is going to talk to you more about tests and their independence. Optimizing test suites. Now that's how we get into getting our tests that we can run continuously. You know, when we used to have, back in the waterfall days, and even in Agile, we build these wonderful test suites, especially regression test suites, and they run overnight. Well, in continuous testing, that's a bottleneck. We can't have test suites that run overnight. So we need to make sure that our test suites are optimized. We want to make sure that every test is giving us the most information for the smallest amount of test. It's kind of like, you got to get your biggest bang for your buck. So in these test suites, we need to validate. We want to make sure we're validating the highest risk areas of code. Now, how do we get that information? Well, we talk to our developers. And that's about the DevOps culture. We're all a team in the DevOps culture. We need to be able to run over to the developer and say, hey, what other areas do I need to be testing for this particular feature? Because sometimes as a tester, you may not be aware that something that you think is pretty straightforward may impact several other areas of the code. Now we need to include test cases. We want to make sure we include the test cases that validate the customer-centric features. How do we find out those? Well, we talk to our business. We talk to our product owners. We also could talk to our help desk, because they're the ones that are closest to the customers. They know what the questions coming in are. They know what features are most important to the customers. And that's the same for validating the critical business workflows. Again, your business folks and your help desk are going to be the ones that can tell you what those workflows are. And those are the ones that you have to make sure you cover. Then you want to make sure your automation tools create multi-purpose scripts. Again, it's about keeping your test suite as small, as quick, as streamlined, and as functional as possible. So we want to make sure that our test scripts cover cross-platform. We want to be able to run our scripts on desktop, web, mobile, server, wherever they need to run, and we shouldn't have to have separate scripts. We want to make sure that they function on all the browsers, including Chrome, Edge, Safari, any other browsers that are very important to our particular application. And finally, we can even include performance testing in running our scripts, because if we use scripts that can collect performance statistics, including the page load times and that kind of stuff. So that's all about, using the tests for multi-purposes. That's all about getting the most bang for the buck in the least amount of testing. So at this point, I'd like to turn the presentation over to Nikolay so he can go into detail about test automation. Nikolay?
Hi everyone. As I mentioned previously, my name is Nikolay. I'm a solution architect here at Sauce Labs. Hope everyone is having a fantastic day or night wherever you are, and thank you so much, Gerie. So Gerie basically gave you all an overview of your continuous testing strategy and how you should implement it, and I'm here to help you better understand how you should implement test automation so that it fits better into your entire continuous testing strategy so that you can get closer to the continuous delivery unicorn. So, oh, sorry about that. Not sure what happened. There we go. So this is basically everything that Gerie has covered in the previous slides. And we were all here in a previous model, in the waterfall model. That's where most of the things were manual. Our dev and QA were completely separate, and we were working in isolated environments. And today, many companies are trying to move towards this goal of continuous delivery. That's basically everything that Gerie has covered, talking about how we want to deliver our product to the production environment on a regular basis, right? Some companies, such as Facebook, delivers twice a day. Amazon delivers like every 11 seconds to production. So there's multiple levels of continuous delivery, but this is basically what everybody's trying to achieve, right? Instead of spending weeks or months or sometimes even years, hopefully no companies are spending years anymore to release to production. We're trying to get to production on a more regular cadence, release much smaller features, much faster, and obviously test automation is a key component of that. So the very first piece I want to talk about is why automation is important. And it's important that you use test automation in order to strive towards reliability. So I find a lot of individuals and a lot of our clients, a lot of test automation engineers, they start on thinking as test automation as basically a way to cover test coverage for the entire test automation suite. And that's an okay way to think about it. But the problem comes into play whenever automation engineers forget about reliability and good feedback from test automation, and instead they work on automating more. So for example, they might automate a couple of test cases, and those couple test cases are passing okay, but sometimes there might be some flakiness in a test case, especially with UI test automation. UI test automation is known to be very flaky because it just has so many components to travel through, right? It has to talk to the HTML, and the HTML has to talk to the API. The API has to talk to the code, and all of those components have to interact together. And so sometimes UI automation is known to be flaky. So whenever they get that flakiness in their test automation suite, instead of pausing and fixing that test automation, they actually continue to automate further and further, continuing to grow their test automation suite. And that's a huge problem because over time, the flakiness continues to be magnified in the entire test automation suite. And so it's really important that instead of focusing on adding more test automation, focus on reliability as the #1 component. So you add tests and make sure that they are passing extremely regularly. I would recommend that if a test runs 1,000 times, 995 of those times, your test should pass with the appropriate result. Meaning if it's a pass, it's a pass. And if it fails, it means that it should fail with an actual bug and not any kind of flakiness in your code. The other really important component here is to make sure that you execute your tests regularly. Daily is the minimum in And what we see a lot of our top performing clients and a lot of the best automation engineers that I've worked with, they execute their test automation regularly. The ultimate desire for continuous delivery is you're actually going to be executing your test automation on a pull request, right? So code is going to be getting checked in on a maybe every minute basis, multiple times, per hour basis, and your automation should be running all of those times. The reason for that is it's because it's going to provide you feedback from your test automation about not only the state of your application, but you're also going to know how your test automation is doing. And so that will allow you to find any kind of problems in your test automation, and you'll be able to remove those problems from your test automation and make sure that it is more stable. The final point I want to make here about striving towards reliability is to make sure that you don't automate everything just for the sake of automation. As Gerie spoke about, there is the test automation pyramid, and there are appropriate levels of test automation for different kinds of scenarios, right? If you're doing something like a calculator functionality and you want to make sure that 2 + 2 = 4, that's something that can be done at the unit level. It does not need to be done at the UI level, or it could even be done at the API level layer if it's a web application, for example. And our managers, they're great individuals, but a lot of times they don't have the technical expertise to tell us what to automate and what not to automate. And a lot of times I've seen where managers will say, hey, here's a suite of 4,000 tests. Let's just go ahead and automate it at the UI layer. So we need to be the experts during that time and say, no, it does not make sense to automate all of these test cases at the UI layer simply because it's just going to be a waste of the company's money. At some point it become unmaintainable, and they will be able to be pushed down to lower levels of the test automation pyramid. So that's what we must do as experts in the field. As automation engineers, we need to say no and realize the appropriate scenarios for using UI automation. So another very common problem that comes in test automation is duplication. And as Bob Martin said, I'm not sure if you're familiar with Bob Martin, but he's a phenomenal software developer. He's been developing software since like the dinosaur age, and he says that duplication is the primary enemy of a well-designed system. The problem with duplication is that it causes us to do extra work whenever we have a change that's inevitably coming, right? We've all worked with UIs, and we all know how UIs change, right? Whether it's different versions of your applications or whether you're moving to different browsers and operating systems, the UI is always changing. So whenever that UI changes, we need to be able to handle that change. And by removing duplication, we'll be able to remove extra work that we need to do whenever that change comes. Duplication can come in multiple different forms. Here's an example of a very poorly written automated Selenium test. And you can see some common duplication here. For example, I'm using this element here to interact with this user email, and we're clicking, we're clearing, we're sending keys, and then there's this password element that's also clicking, clearing, and sending keys. This is an obvious, very obvious form of duplication because it's right there, right in front of you. You can see it, right? It's literally duplicate lines of code with just a different method at the end. So a very easy solution for this is just put this element inside of a property of a page object. Now, if this element lives inside of a property of a page object, all you have to do is go in there and change the locator, and whenever the locator changes, you can now just update it in that single page object, and it will be updated in all of your tests. There are higher levels of duplication that can occur in test automation. For example, you can see here that we have two tests. These tests are actually using different kind of functions. But if you look inside of the tests themselves, you can see that there's even duplication occurring between the tests, not in just a single test, but between the tests. So look, for example, here we're initializing a driver, then there's this try-catch block here, try-catch block here, then in here we're even doing the same steps where we're going to some page, we're clicking some information, then we're handling some text, and here we're doing the exact same thing. So this is duplication because, again, if any of these steps change, for example, what if instead of clicking the account link, now you also need to do a CAPTCHA or maybe you need to enter some text. And so if you have that extra addition in your test case, you're now going to come in and you're going to have to update every single test where these methods in this order are no longer correct. And so instead, again, you can use something like a page object to encapsulate all of this inside of a method. And maybe, to me, this method seems like a login method, right? So maybe all of this can just be simply placed inside of a login method. And so now this is going to perform all of the appropriate actions that you need in order to log into your application. And so if the change comes, you just go inside of that login method, update the appropriate steps, and they'll be reflected in all of your automated tests. Now, one very important topic I also want to talk about is running your tests in parallel. Running tests in parallel is easily the best and the most useful way to do test automation. The test automation is beautiful because, right, it's robust, it's repeatable, it's usually quick to run. But then the other beauty about test automation, and especially if you can do it in parallel, is that you can run 100 or 1,000 or even 10,000 tests at the same time. So what that means is we can strive for an amazingly fast feedback loop in our continuous delivery environment. So for example, you can see this very top row here, and this total time to sweet feedback is what we are really after, right? If we want a continuous delivery environment, a very good feedback loop from your test automation is something like a 10-minute feedback loop. But that also includes software building, software compiling, and running all of the tests. So if you want an extremely good test feedback loop, then you want to have your entire test automation run in a minute. And so here you can see that I've set all the automated tests at 100, and so that we're going to keep this variable the same. And if we have 100 tests running at a minute apiece, and we have 100 parallel virtual machines, we'll be able to achieve this gold standard. A lot of our clients or other test automation engineers forget about parallelization as a way to help them, and so what they actually do is, instead of scaling horizontally, they scale vertically. And so they're going to have 100 tests, and each of their tests still takes a minute to run, but they don't do any parallelization, right? So they only execute sequentially, one test at a time, right? Test 1, test 2, test 3, test 4. And so what happens is their test time to sweet feedback is going to be 100 minutes long, which is 100 times slower than this feedback loop. And that is only 100 tests. And so you can see that this is a huge problem that a lot of our clients face, is their suite grows so large that the sweet feedback time becomes so big that continuous delivery actually becomes impossible, because their entire test suite takes 8 hours, 9 hours, or even running overnight, as Gerie talked about. Here's another different scenario that a lot of our clients encounter as well. Again, you can see we have 100 tests, but each of our tests is taking 20 minutes, or you can even pretend even a single test taking 20 minutes to run. It doesn't matter how many virtual machines, how many resources you throw at it. At the end of the day, your entire test suite feedback is going to be 20 minutes, because your entire automation suite will run as fast as your slowest test. So if your slowest test is 20 minutes, it doesn't matter what you do, your test feedback loop is going to be 20 minutes. So this is going to be 20 times slower, no matter how many resources you throw at it. So keep this in mind, because I'm going to help you to get to parallelization. I'm going to give you some techniques on how to achieve parallelization, but ultimately, this is the scenario that you're shooting for, to get that 10-minute continuous delivery cycle feedback time. So how do you actually achieve parallelization with your test automation? Well, I've got 5 requirements here that you need in order to achieve parallelization. And number 3, it's not technically a mandatory requirement, but it is highly recommended. And in order to, get that fast feedback loop, you want to utilize number 3, and I'll talk about that more as I get there. So let's talk about creating atomic tests. Atomic tests are extremely important when it comes to parallelization. And what that means is your atomic tests, they should be testing only a single thing. So what you can see here is I have a very well-coded UI test that uses the page object pattern. And it's not actually testing one thing. It's not atomic. This is an anti-pattern right here. As you can see, for example, here, we're checking that this Ultimate QA homepage, that it's visible. We're also checking that all the links are working. Then we are using this blog page here. We're checking that the blog page is visible. And then we're also checking that all links are working on the blog page. So the problem with non-atomic tests is that, let's say, for example, that line 9 is where your test case fails, right? Your Ultimate QA homepage doesn't load up for some reason. This means that any line afterwards will never be tested, which means you have a gap in your coverage because your test can't touch any of these other features because, right, your test failed at line 9. So that's a problem with atomic tests, and you want to make sure that you have atomic tests. So here is how you can better actually create the atomic tests. So take a look here. I took the test that we had previously and split it up into 2 tests. So now you can see we have our sample application page, and actually these are 2 different tests, but it's still kind of similar. So you can see that here we're using the Ultimate QA homepage, and we're checking that it's visible, and boom, that's it. That is the test case. There's a single assertion in there, and that is the functionality that we're testing. There is no other functionality that's being checked in here, and if this fails, then we know that our Ultimate QA homepage is not visible. And here's another test that was broken out from there, is you can see that we're using the blog page, and we're just opening up a blog page and validating that it's visible. Again, another totally separate feature being tested. And yes, this is 2 tests, and if you're trying to scale vertically, right, 1 test at a time, each of these tests will probably be longer to run than that single giant test. But if you can parallelize, and each of these tests will take about 10 to 15 seconds to execute locally, you can actually run 2 of these tests in 15 seconds when you can run in parallel. Point number 2 about making sure that you have parallel tests is make sure that your tests are autonomous. Autonomous simply means that it's self-isolated. One of the biggest issues that can happen with parallelization and make it impossible for you is when you can start using the result of one test in the test that it comes after it. So for example, you have test case 1 that executes and it does some actions and leaves the application in some state, and then test case 2 picks up where that test left off and now continues, and test case 3 might pick up after that, and so on. So that is a huge problem because you can never run those tests in parallel, because test 1, test 2, and test 3 will all depend on each other, because you have to run test 1 before you have to run test 2, and so on. And so that will make it impossible for you to run tests in parallel simply because they're so tied up. And the other problem with non-autonomous tests is that what happens if test 1 fails? It means that test 2 is automatically going to fail. But does that mean that the functionality of test 2 doesn't work? No, not necessarily, because test 1 is broken. That doesn't mean that the functionality of test 2 is broken. But because your test 1 failed and test 2 depends on it, now you have broken 2 tests, and one of them you have no idea whether the functionality works or not. So here's the third requirement for keeping and making your tests parallel. Again, as I said, it's not 100% mandatory, but it's highly, highly, highly recommended because it will allow you to achieve that really fast continuous feedback loop. So here are some quick tests that I've given you examples of. These tests are as simple as they get, which is the way you want to do your test automation. So here is that test 1 test that we talked about. Here we're just opening up this Ultimate QA homepage and validating that it's visible. Here's another very quick test, right, that you've already seen, utilizing that blog page. These are tests that are quick. They run about 10 to 15 seconds on your local environment. And my strong recommendation, and I've seen this work very well in the past, is keep your test to a maximum of a minute long on your local environment. That will be plenty of time for you to test what you need to test, but kind of use it as a rule of thumb, get started there. If you like that rule, I just kind of want to throw it out there so you can use it. And if you like it, go ahead and use it. If not, you can adjust, but it's kind of to help you get started. But again, a minute long max on your local resources, and that will be a good rule of thumb because, again, it will allow you to get to that continuous testing, continuous delivery pipeline. The final, or not the final piece, but the fourth piece of making sure that you can parallelize your tests is to make sure that you manage your test data. This is probably one of the biggest challenges that all of our clients face is with test data management. It just simply becomes really hard for them to appropriately use test data in order to execute tests in parallel. So some examples of where test data management can go badly is when you start hard-coding your test data. When you start hard-coding your test data into tests, what may happen when you run in parallel is tests may start stepping on each other, right? Maybe you're using the same user in multiple tests, and one user logs in, and while he's logged in and doing stuff, another test comes and uses that same exact user and starts manipulating the user interface as well. And now these two tests are stepping on each other's toes, throwing off the test user preferences and stuff like that. And so when that happens, you'll never be able to parallelize. And so what we recommend you do is what we call just-in-time data management. It simply means that you create your data when you need it and you delete it as necessary. I myself love code examples, so I've thrown a perfect code example here for you all just to kind of emphasize how you could do that. So here's an example using the Amazon API. This is a made-up test because I didn't actually use the API, but it's just kind of an example of how you can do it. So here we are actually creating test data, right? So we're going to use the Amazon API, right? So we're using a RESTful API to create a test user. And so now we have this test user stored, and we use an API, which means it executed really quickly, and it's extremely robust. This is probably like 150 milliseconds, maybe a 1 second call right here. And now we're going to use the user interface to use the login page. We're going to log in with that test user, and we're going to validate that the login page is visible. And afterwards, we clean up this test user that we created so that we don't fill up our database and the database doesn't grow in size and then crash our applications. And so that's just-in-time data management. And here is the final piece about running tests in parallel. Unfortunately, I don't see this talked about very often, but there is nothing that will stop you from doing parallelization faster than using the static keyword, especially for something like using a driver. So if you do, for a web driver, for example, using with Selenium. So if you do something like use a static keyword for Selenium web driver or your Appium driver or any kind of UI test automation tool that you're using, what's going to happen is now you've created a single space in memory that where all of your tests are going to start accessing that driver. And if one driver is opening up the Amazon homepage, for example, and another driver is trying to search in that page, they're going to start stepping on each other because they're all utilizing a single instance of that driver. And your test will never work because all of them will be stepping on each other's toes. So don't use the static keyword. This is kind of, again, just a rule of thumb from me to you, just to let you know, there are obviously times where you can use the static keyword, especially for like strings, right? If you want to have a static string, that's not a problem. If you want to have like a logging class, you can have a static logging class, but just remember that the static keyword can cause you a lot of problems, especially with using like a driver. So I kind of just give it to you as a rule of thumb. Start there. Don't use it. And then if you want to further talk about some edge cases where you might actually be able to use it, I'm here to help you with that as well. So now I just wanted to show you a quick demo about everything that I've talked about, just run some actual tests so that you can better see it in action, right? Because demos are much more fun than me talking here for 20 minutes. So let me show you that demo. So here I've got a bunch of tests. I'm just going to go ahead and start running these tests. It's actually 54 cross-browser tests. So you can see here what the tests look like. I'm just using opening up Sauce Labs homepage and making sure that the Sauce Labs homepage is visible. And then if we go to the Sauce Labs UI, what you're going to see here is I now actually have started 22 concurrent sessions. So that means that I'm running 22 tests in parallel. Sadly, that's all my virtual machine can handle. I have up to 100 sessions that I can run, but my little puny virtual machine can only run 22 virtual sessions at the same time. And so you can see that here I have a bunch of tests that are now being executed. It's very cool to see because these are cross-browser tests, right? This is a single test making sure that the Sauce Labs page opens up on different environments, right? So here you can see it's running on Mac and it's running on Firefox. Here it's running on Mac and Safari. We're using different Windows versions. Right here's Windows 10 and Edge, Windows 10 and Chrome, and so on and so forth. You can see all of these tests being executed here. And here is how I configured it. You can see that my test is really small, right? This is that third point that I was talking about, keep your tests quick. And you can also see how I configured all of my tests to execute right here. And then what's really cool is if we go here to the automated builds and we take a look, the test that I executed, if I move, you can see that we executed 54 tests in 2 minutes and 22 seconds, which is a pretty great time for your test automation. So you can, I've actually had it run even faster in 50 seconds, and that's pretty fantastic for 54 tests, right? And if I could have a more powerful virtual machine, I could actually have all 100 tests running at the same time and get them into as fast as 50 seconds. And again, as I talked about with parallelization, it's so important because you can see that this is how long all of my tests take. And so our test suite feedback time is going to be as slow as our slowest test. And so if our tests are this fast, then our test feedback time is never going to be slow, especially as we can continue to add more virtual machines and scale horizontally. So with that, I'm going to pass it over to Sarah.
So I think now we're ready to summarize, take a look at just a quick overview of what we talked about. All right, so the most important thing to remember about continuous testing is that it focuses on reducing business risk. That's really what we're doing, and the way we optimize business risk, reduce business risk, is optimize the test process through test optimization of both the scope, the test cases, and the test suite. We put in automated checkpoints and automated feedback loops so that we know when there's an issue and we can catch it right away. And we integrate testing through the entire pipeline, not just at each testing stage. We need to even test the deployments. Mature test automation enables continuous testing. Tests need to be maintained and must be accounted for. We need to use the best practices to implement parallelization that Nikolay talked about, and those were keeping our tests atomic, one script, one test. We don't want multiple things tested in the same script. We want our tests to be autonomous. We don't want our second test to be relying on the results of our first test. We need to keep our tests moving quick. We want to keep each test to running a minute on our local environment. And then finally, we want to make sure we manage the staticness of our tests. So overall, those are our best practices, and that's what's really important about parallelism, because parallelism is what is going to enable the big high speeds. If we run one test at a time, we aren't going to get the test coverage that we need at the amount of time that we have. So parallelism enables the high-speed testing and gives us the high coverage we need. So I think it's time for questions and answers now.
Okay, so I've got some questions here, so let's jump in. How can you create atomic and small tests when you have very large end-to-end automation scenarios?
I can tell you at a high level, basically, you break them all down into multiple tests. Nikolay, maybe you can give us a more technical answer.
Yeah, that's a fantastic answer, Gerie. But yeah, definitely one of the most common questions that we get whenever I do the parallelization presentation is definitely one of the most common questions that we get from all of our clients, right? Some clients have 30-minute, 90-minute tests that are executing, and they're like, hey, how do I get to page number 75 if I have to go through 74 pages? How do I break that test up? Well, it's not, first of all, it's not an easy approach to take, especially if your organization is not structured correctly. But I'll give an example. Imagine you have an Amazon shopping cart, and in your Amazon shopping cart, right, let's say you want to search for an item, you want to, you find that item, then you want to add it to your cart, and then you want to do the checkout process, right? So that's your end-to-end scenario, right? If you're automating that entire thing, it might take a little bit of time. That's not a huge scenario to automate through the user interface layer, but it could still be broken up. And I would break it up into these scenarios. First, I would open up the Amazon page and I would search for an item. Boom, that's test case 1 right there. If that test case passes, I now know that searching for an item works. The next test I would do is using something like a RESTful API or a SOAP API. You can also inject data into the database. For example, if you want to open up the Amazon page and already want to have a search query passed into the URL. I don't know if you all ever looked at actually the Amazon URL, but they pass in query parameters there where they know what you searched for, so you can actually pull up that page that you want to search for the item just using a simple URL. You don't actually have to type anything into the field and hit the enter button. So you can pull up the item just like that using an API, right? API is very robust and it's going to be very quick. And then I can use the user interface to simply add an item to the cart. That's test 2, right? So now we know that we can add an item to a cart. And then the third test would be, can I actually check out the item? And I wouldn't search for the item. I wouldn't put the item in my cart through the user interface. Instead, I would do something like an API call or inject some data into the database or even use a cookie to populate my cart, right? All of these actions are very fast and very robust. And once that's populated, I would then use the user interface, log in as that user, and simply do the checkout process through the UI. So now we would have 3 much smaller tests, and now they can be parallelized. I hope that answers your question.
Wonderful, thank you. Next question here. What is the longest that a UI automation test should run?
Oh yeah, another great question. So again, as I threw that out there through my presentation, a good rule of thumb, something that I've seen work really, really well in the past, is keep it to a minute maximum on your local resources. So in Sauce Labs, for example, it will run a little bit slower simply because of the latency. But if you use that rule, a minute max on your local resources, that should be a very good starting point for you to try and shoot for. And then, you can play around with that number. If you need a minute 15 to accomplish some very quick, very critical scenarios, go for it. But I think a minute is a good starting point for that.
Okay. Another question here I think we've got time for. Any good pointers and or online material for understanding and figuring out when automating at a lower level than UI, Unit API, is preferred? I do automation for Android Espresso, focusing on UI, but would love to know how to identify test cases or app functionality that is better covered by lower level tests, which can also be automated. I don't know if you can answer that. Who wants to go for that one?
That's a really good question. Something that I would need to research. Nikolay, do you know offhand?
Yeah, unfortunately, I was going to say there aren't a lot of resources. I run a blog, ultimateqa.com, and all my students come there and always ask that question. Some of my favorite resources that I've seen, there's Beaufort Fairmont. I think it's BeaufortFairmont.com is the website. The guy there, he runs some excellent webinars on API testing, and he teaches really well. And then there's also the blog called On Test Automation. It's Bass, and his name is Bass. I don't know how to pronounce his last name. I think he's like Polish or something like that. So it's hard, one of those hard Slavic names to pronounce. But he does also a fantastic job teaching API test automation as well. I think he has some webinars and he blogs on it about as well. So I would go to those 2 guys to check out their information. And unfortunately, those are like the best resources that I know for RESTful and API testing. Sorry, I couldn't be more help.
Thank you very much for that. Unfortunately, we're out of time, but any other questions that were in the panel there, we will answer outside the webinar. We've got your email address attached to your questions, so we will come back to you on any additional ones there we haven't had time to answer now. So the webinar has now concluded. Thank you very much to our presenters for such an informative webinar. I've learned a lot, and I'm not even a tester. So, so thank you very much, and thank you to our viewers for your attendance. Just a reminder before we go, recording of this webinar will be available on demand within the next 48 hours, and we'll also email a copy of the recording to you. So in the meantime, we look forward to welcoming you at our next webinar. Until then, goodbye from me, goodbye from Nikolay and Gerie. Goodbye.